welcome to another episode about Rust, the programming language. So we're still slow rolling in chapter 4 about understanding ownership. So I'm up to section 4.2. Obviously these videos are going to be quite a different experience than if I did a conventional training video for Rust, because this is completely unedited. And so what you're getting here is the experience of me struggling to learn a new programming language in real time, based on whatever I've had time to go through that week. And so we're up to section 4.2 in chapter 4 of the Rust programming language. As I mentioned in previous episodes, the nice thing with this is the document in question is available for free online. If you want, you can buy a physical copy of the book or a digital copy, but here it is. Now, in the last episode, we were talking about ownership, and at the end, I was mentioning about, passing stuff between functions. And although I didn't go through any examples, I did suggest that you read the bit at the end, which is on return values and scope. These things here. Now, what happens in the book is they sort of show you that as an example where if you take a certain route with ownerships, things can get complicated. There's a lot of what they call too much ceremony for a concept that should be common, but we can use references, and that's what this week's episode is about. It's about a couple of things. It's about referencing, and it is also about something called borrowing as well. So references and borrowing. And again, I've got the code that I've taken from the book. I've modified it slightly so I can have it in a single main block without copying and pasting code into it. So you'll see there's all sorts of reminders to myself to uncomment code to show you what happens when things break. Because also what I love about this book, and I've said it multiple times, is they're great at showing you what happens when it goes wrong. And also the compiler is great at flagging up and offering you suggestions about how to fix it. So we're going to play around with that. So in section 4.1, listing 4-5, it's shown how if we want to let a function use a value but not take ownership, things can get quite complicated and result in us passing ownership backward and forward with the function. Now Rust has a feature for using a value without transferring an ownership called references, and that's really useful in functions. So once again, I recommend you read through section 4.2 this week to get an understanding of what's going on in the background, because I'm not going to necessarily be explaining that. I'm just going to show you what happens from the code side of things. Again, I'm deliberately sticking to the way the examples are given in the book, so they're really nice and simple, and they do things that probably you wouldn't normally think of doing or do, but they're good for illustrating things. So in the first example, we have this function here called calculate length, which in essence is just going to really just call the method on the value that we pass. Now, what we want to do is we want to use referencing to do this. And so here's where we're doing this. Now, obviously previously to this, we would have had to have assigned a value to S1, our variable. So we're just taking here, we're making a string variable from our literal here and assigning it to the variable S1. We're then taking S1 and calculating the length of it. That's the name of our function, and returning it into the conveniently named len variable. And obviously we're using a let statement there to do that. Now in this example we're using references, so this is where this ampersand symbol comes in. So it's ampersand followed by the variable name, and the ampersand S1 syntax lets us create a reference to the value of S1 without ownership. Therefore, the value it points to will not get dropped when the reference stops being used in the function, and notice the corresponding syntax in the signature of the function with respect to the type of parameter. So because we're sort of using this reference here in the function, when we create our function down here, you can see here we're saying that it's a string pointer. I'm sorry, I think it's a string reference. It's a string reference. And of course there is our, of the value we're returning, because that's where we define the value we're returning is U size. It's the type of the value we're returning. So it's simply here, it's just applying the len method to this S value here. And so, not surprisingly, the length of hello is 5. We're using the result of len in this print statement here. Pretty straightforward. Now, what's interesting to see in this example is what would happen if you attempt to modify a borrowed value. So, we've got this thing of references and borrowing going on here, but in this one we're simply not doing anything with it apart from printing it. What if we start to do some manipulation on it in some way? So what I'm going to do here is, we've got this function called change, and what the function called change does, if we look down here, here it is, here's this version of change. So it's going to modify some string in some way when we do that. So I'm going to, actually what I should have done, before I do that, just avoid any unpleasantness here that we might have. So we're going to uncomment that, and we're going to uncomment the function. There we go. Save that and see what sort of hell breaks loose. Okay, some string is a ampersand reference, so the data it refers to cannot be borrowed as mutable. So you can see here, if we go back up again, here we're trying to attempt to modify a borrowed value using references. But Rust is saying, no, you can't. If you try and push that down here, if we try and push this string literal onto the sum string variable, it's not having any of it, because it's a reference. So we can't do it that way. So how might we do that if that's something we needed to do in a function? So let's comment that out. So just as variables are mutable by default, so are references. And we're not allowed to modify something we have a reference to. With some tweaks, this is what a mutable version would look like. So you can see here, and I've also included like a before and after as well for this particular one. So if you sort of look at the slight difference between the way the syntax is listed here, just ignoring the print statements for a moment, just focusing on this as compared to this, you can see we've got mute in there. And then this as compared to this, we've got ampersand mute in there. And then we go down to the function, and you can see the difference between, say, this one that I've commented out now and this one. You can see now you've got ampersand mutable in here, whereas, and then string, as before it was this. And then here there's no difference. So it is again purely in the nature in which things are referenced, and also how they are defined in their original variable definition. So now if we run this, hopefully what did I do? Oh, yep. Easy mistake to make, eh? How many times have we all done that? Recompiled before we actually saved the source code. Hands up, everybody. So you can see here, this was just to prove I was getting output, but no problems there. So as variables are immutable by default, so are references, and we're not allowed to modify something we have a reference to. With some tweaks here, this is what the mutable version looks like. So, and I've just restated here, we changed the S2 to be mutable, then we create a mutable reference with ampersand mute S2, I should say, where we call the change function, then update the function signature to accept a mutable reference with some string, ampersand mute string. So that's how that's done there. But there is a big restriction. If you have a mutable reference to a value, you can have no other references to that value. So I'm going to uncomment the following code just to see what happens. Now you want to read the section in the book on data races as to why Rust prevents this, but this is just seeing what happens if you attempt to have multiple references for multiple mutable references in this. So yeah, beware of multiple mutable references. I don't think there's anything else down here. No, got something about dangling in a moment. Funny. Okay. What did I do? Oh, yeah. Okay, so you can see here we've got a reference here, but we're referencing it again, so we're doing it more than once, and you can't do that. And I'll show you in a moment how it can be done. You've probably already seen in the following example. But here it's not happy. So here's our first mutable borrow occurs, and then we've got a second one. And then we try and use that first borrow later as well. So several things going on here, but it's a problem because of this multiple mutable references going on. So how might we get around that, or how in Rust in the book do they recommend that that you avoid that from happening? So basically what we do is we use curly braces to create a new scope to allow for the multiple references rather than simultaneously. So the problem is that they're happening, one after the other simultaneously. Whereas if we control the scope, we can make a new reference with no problem. So the code, if I remember to save this again, works fine now. We get our first mutable reference here in this code block, which creates its own scope, and then we can quite happily have another reference to S here, which is outside the scope of this code block. So that's how you might get around that if you want to do it. And Rust enforces a similar rule for combining mutable and immutable references. So check out section 4.2 if you want to read around that and what it looks like in the code. Now, when you're using pointers in a language, so what you might find is it's easier to erroneously create what's called a dangling pointer. So a pointer that references a location in memory that may have been given to something else. By freeing some memory while preserving a pointer to that memory. So, that's the scenario. You've got a pointer that references a location in a memory that may be given to someone else, and then you've tried to free up some memory while preserving a pointer to that memory, and you create these dangling pointers. So let's uncomment this and see what happens in Rust if we attempt to do this. Now I think I'm going to have to also uncomment my dangle function, which helps cause the dangling scenario. Let's see what happens when we run this. Okay, this function return type contains a borrowed value, but there is no value to be borrowed from. Expected name lifetime parameter. So because S is, let me just see this, because S is created inside Dangle, so here's my Dangle function. When the code of Dangle is finished, S will be deallocated, but we tried to return a reference to it. That means that this reference would be pointing to an invalid string. The solution here is to return the string directly by changing the function to remove the ampersand. So let's try that. If we do that now, see if that works. And there we go, it's now working. It just basically returns hello again. So just a few things there when you're working with references, borrowing, pointers, those sort of things. Stuff to watch out for, particularly here with functions. But there was another example that wasn't specifically a function, I don't think. Let me just try and find it again. Yeah, this one here. So yeah, a few things to think about, and definitely if you want to understand what's going on in the background, definitely read through that section 4.2, because again there's a really good explanation. Let me just bring it up on screen here. Here, in terms of what sort of goes on in memory in the various places for when you're sort of working through some of this code. The other nice thing with the book as well is it includes all of the error messages here as well. So that's really cool. It is fun to run them to see what happens in real life, but I do like that it's actually like a screenshot of the actual error. And this I've said it multiple times, but I just love this compiler. It's just fantastic. So yeah, thumbs up, multiple thumbs up to the designers of this language. Great work in this. So thanks once again for watching. Bye for now, and I will see you in the next episode.